Hello students. In the series of mathematics for high school physics, we started discussing calculus. In calculus, we have seen already what is the meaning of derivative of y with respect to x. We have seen what is the meaning of dy by dx, how to find the derivative of different functions. We also discussed that. We wrote down all the basic formulae. We did not just write down all the basic formulae. We also derived those formulae. And we also wrote down rules of differentiation like addition rule, subtraction rule, multiplication rule, and division rule. Now, let us discuss how to write the derivatives of inverse trigonometric functions. What is an inverse trigonometric function? Inverse trigonometric function is basically angle, right? For example, if I have y is equal to sine x, what is x here? X is angle. Y is the ratio. Y is the ratio of two sides in a right angled triangle, and x is the angle. This expression can be written as x is equal to sine inverse of y. For example, we know sine 30 degrees is equal to 1 by 2. It means 30 degrees is equal to sine inverse of half. So half is the ratio of sides in a right angled triangle and 30 degrees is the angle. So we are writing angle as a function of ratio of sides in a right angled triangle. Okay, when we write y is equal to sine x or cos x or tan x, what it means is we are writing ratio of sides as a function of angle. X is angle here, y is the ratio of sides in right angled triangle. If we write down this equation as the following, x is equal to tan inverse of y. So we are writing angle as a function of ratio of sides. Ratio of sides in a right angled triangle. So inverse trigonometric functions are basically angles written as functions of ratio of sides in a right angled triangle. Now let's look at how to find the derivatives of inverse trigonometric functions. Let's discuss how to find the derivatives of inverse trigonometric functions. So we are going to basically discuss three inverse trigonometric functions: sine inverse of x. One is y is equal to sine inverse of x. The second inverse trigonometric function that we are going to discuss is y is equal to cos inverse of x. The third one is y is equal to tan inverse of x. So for these three functions, we are going to discuss how to find dy by dx. We know what dy by dx is. We are going to discuss how to find dy by dx for each of these functions. You know what dy by dx means, right? The rate of change in y with respect to x at a given value of x at a particular point. So that's what we are trying to find out. So we'll find dy by dx, the derivative of y with respect to x, if for sine inverse x, cos inverse x, and tan inverse x. Now let's discuss the first one. Y is equal to sine inverse x. Here y is the angle, x is the ratio of sides. Okay, angle is written as function of ratio of sides. This function can also be written as, to find dy by dx, what I am going to do is, I am going to write this function as x is equal to sine y. Y is equal to sine inverse of x means x is equal to sine y. And I am going to write down dx by dy. We know if y is equal to sine x, we already derived this expression. If y is equal to sine x, we know dy by dx is equal to cos x. Similarly, if x is equal to sine y, dx by dy should be equal to cos y. Dx by dy is equal to cos y. We want dy by dx, reciprocal of dx by dy. So dy by dx is equal to 1 by cos y. We are going to write this in terms of x, the result. So we got the result. We got dy by dx, but we got dy by dx in terms of y. So we are going to write dy by dx in terms of x. Let's see how. We know dy by dx is equal to 1 by cos y. Cos y can be written as square root of 1 minus sine square y. And you know sine y is equal to x. Since sine y is equal to x, I am going to write here dy by dx as 1 by square root of 1 minus x square. In place of sine y, I am substituting x. Sine y whole square is x square. So this is derivative of sine inverse of x. Similarly, we can also write down the derivative of cos inverse of x function. Let's look at the second inverse trigonometric function. Y is equal to cos inverse of x. Since y is equal to cos inverse of x is equal to cos y. If y is cos inverse of x, y is the angle, x is the ratio of sides in a right angled triangle. So x is equal to cos y. Here our task is to find dy by dx. So first I'll find dx by dy. If x is equal to cos y, we know how to find dx by dy. We have seen this formula. Dx by dy is equal to minus sine y. We can write dy by dx as minus 1 by sine y. It's reciprocal. So if we proceed in the similar way like in the previous case here, so dy by dx is equal to minus 1 by square root of 1 minus cos square y. Hence dy by dx is equal to minus 1 by square root of 1 minus x square. Because cos y is equal to x, cos square y is equal to x square. So this is the second inverse trigonometric function and its derivative here. Let's look at the third one. The third one, y is equal to tan inverse of x. Again, we will do it in the same way. Y is equal to tan inverse of x means x is equal to tan y. If x is equal to tan y, dx by dy is equal to what? We know dx by dy is equal to, you know the formula, right? Y is equal to tan x. If y is equal to tan x, we derived this formula in the class in one of the last videos. So dy by dx is equal to secant square x. So if you use that formula, you will get dx by dy is equal to secant square y. Or we can write this as dy by dx is equal to 1 by secant square y. right? Well, we can write this in terms of x by using one of the trigonometric identities. Secant square y minus tan square y is equal to 1. So secant square y can be written as 1 plus tan square y. And tan y is equal to x. So dy by dx is equal to 1 by 1 plus x square, because tan y is x, tan square y is x square. That's how we get dy by dx is equal to 1 plus x square for the function tan inverse of x. So like this, we can write down the derivatives of inverse trigonometric functions. So until now in differentiation, we discussed the meaning of differentiation in physics. We discussed what dy by dx means. We discussed how delta y by delta x and dy by dx are different from each other. Okay. So understanding the meaning of derivative, understanding why we do differentiation in physics is very important. So we discussed the meaning of derivative of y with respect to x. Also, we discussed how to write derivatives of different varieties of functions. If y is equal to x power n, y is equal to sin x, cos x, tan x. For all the trigonometric functions, we wrote down derivatives formulae. For logarithmic functions, exponential functions, also we wrote down the formulae. And here we wrote down derivatives of inverse trigonometric functions. Also, we discussed different rules of differentiation: addition rule, subtraction rule, multiplication rule, division rule, and chain rule. So we discussed different rules of differentiation. Now let us see few basic applications of differentiation in physics. In physics, we come across differentiation at many places. Velocity. How is velocity defined? Velocity is defined as the rate of change in displacement with respect to time. Velocity is displacement covered by a body in a unit time. Go back to the definition of dy by dx that we discussed. What is dy by dx? Rate of change in y with respect to x. Or it is change in y per unit change in x at a given value of x. So at a given value of x, we construct a very small interval around the given value of x. Technically speaking, it is called infinitesimally small interval. In the infinitesimally small interval, as delta x approaches 0, in the infinitesimally small interval, as delta x approaches 0, delta y by delta x approaches a particular value, and that particular value we call it dy by dx. So dy by dx is the rate of change in y with respect to x at a given value of x at an instant. This is at an instant. In the case of time, we call it an instant. Okay. So here, how is velocity defined? Velocity can change with time. At different points of time, velocity of a body may be different. So velocity changes from instant to instant. At different instants of time, velocity can have different values. So how do we write velocity at a particular instant of time? Velocity at a given instant of time is rate of change in displacement with respect to time at that particular instant. So at an instant of time, rate of change in displacement with respect to time is called velocity at that instant, or we also call it instantaneous velocity. Similarly, acceleration. How is acceleration defined? The rate of change in velocity with respect to time is called acceleration. Acceleration is rate of change in velocity with respect to time. Sometimes we don't mention with respect to time, but still it means with respect to time. So this is instantaneous acceleration. Acceleration at a particular instant of time. Similarly, we can write work done. Power is equal to rate of work done with respect to time. Even if we don't mention with respect to time, it means with respect to time. So power is equal to rate of work done. Similarly, net force acting on a body is equal to rate of change in momentum. So like this, we come across the derivatives at many places in physics. So net force is equal to rate of change in momentum. Similarly, a conservative force is equal to minus of potential energy gradient, rate of change in potential energy with respect to position. Electric current is equal to rate of flow of charge with respect to time. So we come across the differentiation at many places in physics. Let's see an example. Example of kinematics. Example of motion of a body. Okay, one simple example. Let's discuss here. We know if a body, you must have seen this equation. S is equal to ut plus half at square. When your body is moving in a straight line with constant acceleration, displacement varies with time according to this equation. Even if you have not heard this equation, just look at this equation as a simple function. S is a variable, t is a variable. The variable s depends on the variable t. So look at this equation as uh, a function in which s depends on t. U and A are constants. This is basically an equation for the displacement of a body moving with constant acceleration. U is initial velocity, A is acceleration. Here, U and A are two constants. U is a constant, A also is a constant. Now, this is displacement at a given point of time t. Let's write down the expression for velocity at a given point of time. Let's write down velocity as a function of time using differentiation method. Velocity at a given point of time. We know velocity by definition is rate of change in displacement with respect to time. So displacement in a unit time. We know V is equal to ds by dt. So that's it. You know how to differentiate this. This is d ut plus half at square by dt. Use the addition rule of differentiation. This now can be written as dut by dt plus d half at square by dt. You know what to do with the constants, right? So these constants come out. U comes out, half into a by 2 also comes out. So here v is equal to u dt by dt plus a by 2 into dt square by dt. Okay, dt by dt is 1. So v is equal to u into 1 plus a by 2 into dt square by dt. You know x power n formula, n into x power n minus 1. So 2 into t power 2 minus 1. Simplify this, you will get v is equal to u plus at. This is velocity as a function of time. Look at velocity. This is velocity at a given instant of time. We can find velocity at a given instant of time by differentiating displacement function. So by differentiating displacement function, we get velocity function. By differentiating velocity function with respect to time, you will get acceleration. Okay. So like this, we apply differentiation techniques at many places in physics. Now let us discuss graphical interpretation of differentiation. What does differentiation mean on a graph? So how do we explain differentiation on a graph? Let's try to understand. Let's draw some arbitrary shaped graph. You know, if y is a function of x, y depends on x. It means y may increase x as x increases, maybe y decreases as x increases, maybe y increases at an increasing rate as x increases. It is possible that y may increase at a decreasing rate as x increases. So there are various varieties of graphs. So graph is a picture in which we understand how y changes as x changes. Like equation, if you look at y is equal to 2x plus 3, this equation tells us how y changes as x changes. So this is mathematical way of understanding how y is changing as x is changing. But when you draw a graph between x and y, we understand pictorially what is happening to y as x is changing. Okay, let us take some arbitrary function. Let's say a graph of this kind is drawn for that function. Okay, we will discuss how to draw the graphs later. But now let's take any shape of the graph that you like. Let's draw a graph like this. Now look at this graph. In this graph, what is happening as x is increasing? As x is increasing, y is also increasing, that you can see. Okay, as x goes to larger and larger values, y is also going towards the larger and larger values. But look at the rate of change. What do we mean by rate of change? Delta y by delta x, or y2 minus y1 by x2 minus x1 is the rate of change in y with respect to x in a given interval of x. This is rate of change in this interval of x. What is dy by dx? Dy by dx is rate of change in y with respect to x at a given value of x. Let's try to understand what it means here. Here, imagine this to be a hill that you are climbing up. Imagine this graph to be a hill that you are climbing up. So look at what is happening to your height as you are taking the steps. For every step, For every step that you take as you climb up, the height is increasing. But is your height increasing at the same rate for every step? Is your height increasing at the same rate for every step? Look at the lower values of x. As you are below the hill, for one step, this is the increase in the height. For the next step, this is the increase in the height. For the third step, this is the increase in the height. For the fourth step, this is the increase in the height. Look at the fifth step, sixth step, seventh step. The hill is getting steeper and steeper as you go towards the higher values of x. Okay, so for every step that you take, height is increasing. But look at the increase in the height at larger values of x. At larger values of x, for every step that you take, the increase in height is more than the increase in height in the lower values of x. It means as you are taking the steps, your height is increasing, but the rate at which your height is increasing is also increasing. The rate at which your height is increasing is also increasing. So per unit step, the increase in height is more at greater values of x. For every one step, the increase in height is more. The graph is steeper. If you look at it as a hill that you are climbing up, the hill is getting steeper and steeper at greater values of x. So here, height increases at different rates at different values of x. Height increases at different rates at different values of x. In fact, we can infer that height increases in this graph that we have drawn. Height increases at increasing rate. Height increases at increasing rate because for one step, look at the increase in the height at lower values of x. For one step, look at the increase in the height at higher values of x. So height is increasing. The increase in height is also increasing. So let's find out delta y by delta x and also dy by dx on the graph. Look at this graph. So what I'm going to do is I'm going to take 2 points on the graph. Let me call this point A. Its coordinates are x1 comma y1, and I'll take one more point B. Its coordinates are x2 and y2. Now between the points A and B, let's find out the slope. So draw a straight line between points A and B. Look at the straight line drawn between A and B. What is the change in y as we go from A to B? Y changes from y1 to y2. X changes from x1 to x2. So here, let me call this point C. AC is change in x in the interval from A to B. X changes from x1 to x2, and y changes from y1 to y2. Y changes from y1 to y2. Now, in the interval from x1 to x2, that is in the interval from A to B, what is the rate of change in y with respect to x? So, from in the interval from x1 to x2, we know rate of change in y with respect to x is delta y by delta x. Rate of change in y with respect to x means change in y per unit change in x. In this case, delta y by delta x are y2 minus y1 by x2 minus x1. This is the rate of change in y with respect to x in the interval from A to B. Well, this does not mean that for every unit change in x, y changes by the same amount. This is average rate of change in y with respect to x. Average rate of change in y with respect to x here. Total change in y divided by total change in x. Here, between A and B, we found a total change in y by total change in x. Well, this does not mean that every part of AB has the same rate of change. No. Every part of AB does not have same rate of change. This is just average rate of change in y with respect to x. Okay. Or we also call this slope. This is also called slope between A and B. This is average slope between A and B. Look, the graph does not have same steepness at every point between A and B. The graph does not have same slope between A and B everywhere. So the graph is less steeper close to A, more steeper close to B. Graph does not have same slope everywhere. This is just an average slope between A and B. Average slope between A and B is delta y by delta x or y2 minus y1 by x2 minus x1. So rate of change in y with respect to x is delta y by delta x is equal to y2 minus y1 by x2 minus x1. Now look at the figure. This straight line joining A and B is called secant line for this curve. A straight line passing through 2 points on a curve is called secant line. If I say this angle is theta here, angle made by the secant line with horizontal is theta. This side BC is, equal to y2 minus y1. This length is y2 minus y1. Similarly, side AC length is equal to x2 minus x1. y2 minus y1 by x2 minus x1 is the ratio of two sides in a right-angled triangle ACB. Look at the right-angled triangle ACB. In the right-angled triangle ACB, y2 minus y1 is opposite side of theta and x2 minus x1 is adjacent side of theta. So this is ratio, slope is ratio of opposite side to adjacent side, ratio of height to base. Okay, and you know this is equal to tan theta, where theta is angle made by the secant line with x-axis. This angle is theta, this angle is also theta. Look at these two angles. These two angles are same. Angle made by the secant line with two parallel lines. Okay, where theta is angle made by secant line with x-axis. This is only average slope. This delta y by delta x is average rate of change in y with respect to x in a given interval of x. But we want to know what the dy by dx means on a graph. What is dy by dx? It is rate of change in y with respect to x at a given value of x. Delta y by delta x is average rate of change in y with respect to x in the given interval from x1 to x2. Right? So we want to know the rate of change in y with respect to x at a given point, at a given value of x. So how do we interpret dy by dx on a graph? That's what we are going to discuss now. Let's look at the same graph again. Look at this graph. I want to find rate of change in y with respect to x at a particular point called P. Let me say the coordinates of P are x comma y. X coordinate of point P is x, y coordinate of point P is y. Now we want to understand what dy by dx means on the graph. What is dx? Dx is infinitesimally small change in x. Okay, change in x that is very close to 0 but not equal to 0. What is dy? Dy is again infinitesimally small change in y. So what we are going to do is, we are going to construct a small interval around x. We are going to see what happens if x changes by a small amount from x to x plus dx. Look at this straight line here. The gap between these two straight lines is only a small quantity. This point is x plus dx. X plus dx. So when x changes from x to x plus dx, look at the graph now. X changes from x to x plus dx. Y changes, let's say, from y to y plus dy. This point here. Look at this point here. That point here has a coordinate y plus dy, y coordinate y plus dy, x coordinate x plus dx. Now draw a secant line passing through those 2 points that are very close to each other. Draw a secant line passing through these 2 points. These 2 points are very close to each other. Since those 2 points are very close to each other, the secant line is almost a tangent. I can say this line is a straight line passing through 1 point on the graph, because as you are making the interval smaller and smaller, okay, the straight line drawn here, we can say, is coming into contact with the curve only at 1 point. Now look at this right angled triangle here. You can't see the right angled triangle. Look at this right angled triangle here. You can see the 2 points. Let me call this, we call this point P, this point Q. Let's call these 2 points P and Q. This point is P, this point, and this point is Q. This distance, this gap is dx, and this gap is dy. It looks like a right angled triangle. I'll redraw the right angled triangle here. So on the graph, you have 2 points P and Q that are very close to each other. This gap between P and Q is dx, and vertical gap between P and Q is dy. So you can say that this is almost a right angled triangle, PQR. You can see PRQ right angled triangle. The points P and Q are very close to each other. The gap is very small, dx. The gap is close to 0, but not equal to 0. And if you draw a tangent, this is almost a tangent. If you draw a straight line passing through point P, this straight line makes an angle theta with x-axis. This straight line, this tangent makes an angle theta with x-axis. Now look at the right angled triangle here. This angle is also equal to theta. Look at the figure. Tan theta, look at this right angled triangle PRQ. In the right angled triangle PRQ, tan theta is equal to dy by dx. Vertical side by horizontal side of the right angled triangle, opposite side by adjacent side. So tan theta is equal to dy by dx is the rate of change in y with respect to x at that particular point. So here, slope of the graph at point P is tan theta dy by dx. So slope of the graph at point P is dy by dx equal to tan theta. So rate of change in y with respect to x at a given value of x is equal to slope at a given point on the graph, which is equal to angle, tan of angle made by the tangent with x-axis. So slope at a given point is equal to tan theta. And what is theta here? Theta is angle made by tangent drawn at P with x-axis. Theta is angle made by the tangent with x-axis. So slope of the graph at a given point is always equal to tan theta. Look at the secant line drawn in the previous graph. Look at this green straight line, green dotted straight line. This is the secant line because this straight line passes through 2 points on the curve. But as the 2 points come very close to each other, this difference decreases. This difference, the horizontal difference, that is x coordinates difference, also decreases. So when the 2 points are very close, the difference is very small, infinitesimally small. The secant line becomes tangent line. So that's when we write dy by dx. Okay, slope of the graph at a particular point, dy by dx is equal to tan theta. Let's draw tangents at different points for the same curve, for the same graph. Let's draw tangents at different points. Draw a tangent here. Call this point A. Let's say angle made by this tangent with x-axis is tan theta 1. Draw a tangent here, say at point B. Now look at the angle made by the tangent with x-axis. Look at the angle made by the tangent with x-axis. Draw a tangent at point C. Look at the angle made by the tangent drawn at point C with x-axis. So what is happening to angles made by the tangents at different points as the x value increases? Look, as you go from A to B and B to C, what is happening to x? X is increasing. I am talking only about this curve. In the curve that we have drawn, in the graph that we have drawn, y increases as x increases. That can be seen from the graph. But what about the rate of change in y with respect to x? What about these angles? Theta also increases as x increases. As x increases, theta increases. Angle made by the tangent at C with x-axis is greater than that at B, and angle made by the tangent at B with x-axis is greater than that at A. So angle theta is increasing as x is increasing. What it means is tan theta also is increasing. Tan theta 3 is greater than tan theta 2, which is greater than tan theta 1. It means slope of the graph increases. So slope at C is greater than slope at B, which is greater than slope at A. Slope of the graph increases. It means the graph becomes steeper and steeper at higher values of x. Slope increases means what? dy by dx increases. dy by dx increases. It means the rate of increase in y increases. So in the graph, we can conclude that y increases as x increases, y increases as x increases, but at what rate? At what rate y is increasing as x is increasing? We would say at an increasing rate. Y increases as x increases at increasing rate. That's what we can understand from here, because the graph is getting steeper and steeper. Let's look at different shapes of the graph and try to understand what is happening as x is increasing. Now we have understood what slope means. Let's understand different shapes of the graphs. Look at this graph. This graph is a straight line. In the straight line graph, x increases as y increases. Look at this straight line. The value of x increases, the value of y also increases. But what is happening to rate of increase in y as x is increasing? dy by dx. What is happening to dy by dx? Because when change in x is positive, change in y is also positive, we would say slope is positive. dy by dx is positive. When change in x is positive, change in y is also positive. X increases, y also increases. So slope is positive. Okay. Now what is happening to the slope? What is happening to the slope? Draw tangent at this is not a curve. Draw a tangent at any point. It makes the same angle with x-axis. Okay. Draw a right angled triangle anywhere. This angle is same as this angle. So delta y by delta x is same for any range of values of x. So theta remains same whether you take a small right angled triangle or a big right angled triangle, whether you take small change in y and small change in x or large change in y and large change in x. We are getting same value of theta. Tan theta is a constant. dy by dx is a constant. What it means is y increases at a constant rate as x increases. So that's the conclusion that we can draw. In this graph, in this straight line graph, the conclusion is y increases at a uniform rate or constant rate as x increases. Uniform rate or constant rate. So dy by dx is a constant here. So if dy by dx is a constant, the graph is a straight line. That we can understand from here. Next, I'll draw one more graph. Look at this graph. This graph is also a straight line. This graph is also a straight line. Look at what is happening to y as x increases. So for x is equal to 0, this is the value of y. But as x increases, y decreases. As x increases, y decreases. Look at the angle made by the straight line or angle made by the tangent drawn to any point on the straight line with x-axis, with positive x-axis, that theta is greater than 90 degrees. Theta is greater than 90 degrees means tan theta is negative. And of course, it's a constant. Why is tan theta negative? Look at dy by dx. Change in x is positive, but change in y is negative. When x increases, y decreases. So tan theta is negative, dy by dx is negative, but it is a constant. Y decreases at a constant rate as x increases. The graph is a straight line. The steepness of the graph is same everywhere. Slope of the graph is same everywhere. So we can conclude that y decreases as x increases at a uniform rate. So that's what we can infer from the shape of the graph. Okay. Negative slope means y decreases as x increases. Let's look at one more graph. The shape of the graph we have seen. We started with this shape of the graph only. Let's look at it again. Look at the slope of the graph at different points. Draw tangent at A. It makes angle theta 1. Draw tangent at B. It makes an angle theta 2. Draw tangent at C. It makes an angle theta 3 with x-axis. Theta increases as x increases. You can see that y increases as x increases, but theta also increases. It means tan theta increases. It means dy by dx increases. So the conclusion is y increases as x increases, but at an increasing rate. At increasing rate. So the graph is initially flat almost, but the graph becomes steeper and steeper at greater values of x. Okay, look at one more. Look at this graph. What is happening to y as x increases? Y increases. As x increases, y also increases. But look at the rate of increase. Initially, y increases at a greater rate, but graph becomes flat at larger values of x. At larger values of x, the rate of increase in y is less. Okay, look at what is happening to height as you are taking steps. Imagine this to be a hill that you are climbing up. Okay, for every step, look at the change in the height. Look at the change in the height for every step. Initially, change in the height is large, but the increase in height, you are increasing your height as you are climbing up the hill, but initial increase in height is more for every step. So increase in height is decreasing for higher values of x. You can say height is increasing, but at a decreasing rate. Okay, slope decreases. Slope decreases. Y does not decrease. Y increases as x increases. But slope decreases. Rate of increase in y decreases. Draw tangents. If you draw tangents at different points, draw tangent at say point A. Look at the angle with positive x-axis. Draw tangent at B. Look at the angle made by the tangent with positive x-axis. Draw tangent at C. Look at the angle made by the tangent with positive x-axis. So what is happening to these angles? Angles are decreasing. It means tan theta decreases. It means the slope or the rate of change in y with respect to x decreases at greater values of x. Here we can say that y increases at decreasing rate. Initially, y increases at a greater pace, but the pace at which y increases decreases. So the graph flattens at larger values of x. Y increases at decreasing rate as x increases. That's the conclusion we can come to in this graph. Like this, we can understand different shapes of the graphs. Let's see a few more. Look at this graph. In this graph, look at what is happening between, say, 2 points A and B. X increases, but Y decreases. Y does not decrease at a constant rate. The graph is not a straight line. If the graph is a straight line, we can say Y decreases at a constant rate. Here slope is negative. Of course, we can understand slope everywhere is negative. But is slope constant at a negative value? No. Look at the steepness of the graph. At different points, if you draw tangents, draw a tangent at P. Look at angle made by the tangent with x-axis. Draw tangent at B. Draw tangent at Q. Look at angle made by the tangent with positive x-axis. So what is happening to this angle? Angle is everywhere greater than 90 degrees. But angle increases. Theta 2 becomes greater than theta 1. Initially, the graph is steeper. Okay, the magnitude of tan theta is high initially. The magnitude of slope is high initially. Initially, the graph is steeper. It means initial rate of decrease is high. Everywhere it is decreasing. But initially, y decreases at a greater rate. But the rate of decrease in y decreases. Initially, y decreases at a greater rate, but later y decreases at a smaller rate. Y is decreasing everywhere, but y decreases at a greater rate initially. Okay. In other words, if I have to give some example of numbers, if the slope is minus 10 here, slope becomes minus 9, slope becomes minus 3, minus 2, minus 1, like that. Magnitude of the slope. Look at the magnitude of the slope. Magnitude of the slope decreases. Okay. So dy by dx is equal to tan theta is decreasing. It means y decreases as x increases, but at a decreasing rate. Okay. So we can understand that y decreases as x increases, but at a decreasing rate. Okay. Similarly, I can give you one more example here. Look at this graph. Look at this graph. What is happening to y as x is increasing? Of course, y is decreasing. Is y decreasing at a constant rate? No, the graph is not a straight line. Let's find out the slope at different points. Look at the slope at different points. Slope at A, slope at B, slope at C. Okay. Initially, the graph is flat. Initially, y decreases at a slower pace. But the rate at which y decreases increases. Okay. It means at higher values of x, y decreases at a greater rate. Or draw tangents at different points. Look at the angle made by the tangents at different points. Draw tangent at B. Let's say angle made by the tangent at B is theta 2 with positive x-axis. Similarly, draw tangent at C. This makes an angle theta 3 with x-axis. Everywhere angle is greater than 90 degrees. But look at the angles. Theta 1 is greater than theta 2, which is greater than theta 3. Angle is greater than 90 degrees, but it is decreasing. It means if the slope is, if I have to give some numbers here slope is -2, maybe here -5, here maybe -9. It means the magnitude of slope or the magnitude of tan theta increases as x increases. So we can conclude that magnitude of tan theta increases means magnitude of dy by dx. Modulus of dy by dx is 2 here. Here it is 5. Here it is 9. Some random numbers I am taking, but look at the numbers. So what is happening to the magnitude of dy by dx increases? It means y decreases at an increasing rate. As x increases, everywhere y is decreasing. But initially y decreases at a slower rate, at a greater rate, and rate further increases. So the conclusion is y decreases as x increases at an increasing rate. At an increasing rate, y is decreasing as x is increasing. This is the conclusion we can come to in the sixth graph. Like this, we can have many shapes of the graphs. Let's see two more. What is happening here? Y increases as x increases, and y becomes maximum at a particular value of x. So y increases as x increases, y becomes maximum at a particular value of x, later y decreases. What is happening to slope? You can see slope is initially high, slope becomes 0 here. Draw a tangent at maximum. If you are climbing up a hill, when you are on the top of the hill, it's flat. So slope there is 0. It has 0 slope. Draw a tangent here. The tangent makes 0 angle with x-axis. The tangent is parallel to x-axis. Okay. So here you can see that y increases and becomes maximum at x is equal to x naught, and then y decreases as x increases. as x keeps increasing, but y increases for first, becomes maximum and then decreases. Look at the slope. Y increases at a decreasing rate. The rate becomes 0 here. And later, y decreases at an increasing rate. Similarly, so we can conclude that at maximum value of y, slope dy by dx or tan theta, where theta is angle made by the tangent, is 0. Similarly, we can look at one more graph. Look at this graph here. First, y decreases, becomes minimum at x is equal to x naught, and then y increases. When y becomes minimum, draw a tangent. Draw a tangent. The tangent is parallel to x-axis. At this point or around this point, in a small interval around the minima or in a small interval around the maxima, the graph is flat. The graph is flat. Slope is 0. So, when y becomes minimum, slope is equal to 0. So what do we understand? Y decreases as x increases, becomes minimum, and then y increases. Y decreases at a decreasing rate and y increases at an increasing rate. Okay. So that's the conclusion we can come to in graph 8. So like this, we can understand what is happening to y as x is changing in the graph. Is y increasing or decreasing? Is y increasing at an increasing rate or decreasing rate? So those things we can understand from the pictures. Now, how to find what is the maximum value of y for any given function? How to find the maximum value of y or the minimum value of y for any given function? And when a function is given, how to draw its graph without putting data points? Putting data points on the graph and joining them and drawing a graph is not professional way of drawing a graph. It is an elementary way of drawing graph. So putting data points and joining them. When a function is given, putting data points and joining them and drawing a graph is an elementary way of drawing graph. So instead of doing it that way, we will see how to draw a graph for any function given to us. So in the next class, we are going to discuss how to find maximum value of y and minimum value of y. What are the conditions for which y becomes maximum and minimum? And we are also going to discuss how to draw a graph for a given function.